Hello and welcome back to the Farmyard Academy. So we've got another video here for you today. We're looking at pH calculations. If you've not seen the revision clip that accompanies the video, I suggest that you watch that first, get the formulas that you need, then have a go at the questions at the top. So you calculate the pH of a strong acid, strong base and a weak acid, and then we'll go through them. Okay, so pause the video, have a go, and then we'll go through them. Alright, so the first one, we've got A, which is a strong acid. The formula for working out pH of a strong acid is pH equals minus log of the H plus ions, like so. So all we're going to do is we're going to go into our question and we're going to see that they've given us a concentration of nitric acid which is 0.55. So we're going to, in our calculator, we're going to go minus log 0.55, and that gives us an answer. So really straightforward, nice and easy, that one. And that's our formula that we need to remember. So pH equals minus log of H plus for a strong acid. One thing to consider is if you've been given diproteinaic acids like sulfuric acid, the only thing that you'd have to do is, if it was sulfuric acid, because this releases two H plus ions, you'd have to times the concentration by 2. So it wouldn't be 0.55 this time, it would be 1.1, because you'll have multiplied the 0.55 by 2. Okay, so next one we're going to do a strong base, and the formula that you need to remember for a strong base is Kw equals H plus over OH minus. So learn that one. We then need to rearrange this formula in order to get H plus, and then we can use our other equation to work out pH. So we're going to rearrange. So H plus, again, remember opposites, these two are being multiplied together. So to get the OH minus over to the one side of the equation and leave the H plus, we do the opposite of multiplication, which is divide, and we're left with Kw divided by OH minus ions. We need to remember that the constant for Kw is 1 times 10 to the minus 14, unless specified in exam questions. It is temperature dependent, but if it's not stated, then you assume it's 1 times 10 to the minus 14. And then we use the concentration of the KOH for the OH minus ions. So it's 1 times 10 to the minus 14 divided by 0.45. Once you've done that, you can use the same equation for pH again, which is pH equals minus log of the answer here. So if that comes out as X, you do minus log in your calculator, and that will get you your overall answer. Okay, so that's how to do strong base. And the final one is a weak acid. So what we're going to do here is we're going to use H plus equals the square root of Ka multiplied by the concentration of the weak acid. We just show that with the simple symbol HA, but it can be any acid. For this instance, we are using ethanoic acid, and it's at 0.3 molar concentration, and it's given us our Ka constant there. So all we've got to do is we do the square root of our Ka constant, which is 1.75 times 10 to the minus 3 multiplied by 0.3, and then all square rooted. That gets you H plus, and then again it's the same again, so it's pH equals minus log of the answer that you've got there, and then that will get you your answer for a weak acid. So 3 formulas to learn. You've got pH equals minus log for a strong acid, Kw equals H plus times OH minus for a strong base, and H plus equals the square root of Ka times HA for a weak acid. Okay, see you on the next one.